In this tutorial, we will look at using Java persistence architecture with Spring Framework repositories in Jakarta JEE 8. The key topics we will cover: Spring repositories and transactions, persistence configuration with JPA, JPA repository design and entity relations, and data transfer objects for efficient data access. Why it matters: we get streamlined database interaction, we get a scalable and maintainable architecture, and we get transaction-safe operations. When we look at Spring repositories and the persistence configuration, you see we use @repository for defining JPA repositories. We use @entitygraph for optimizing entity fetching, and we use @transactional to ensure atomic updates. To set up our persistence, we will use a persistence XML for our MariaDB configuration. We will set up our Hibernate dialects, SQL logging and formatting, and we will ensure that we support OpenJDK 11 and Jakarta Enterprise Edition 8. When we look at optimizing data access with data transfer objects, we are going to create a movie data transfer object to simplify our complex entity relation. And this data transfer object is going to be using a model mapper for seamless conversion. And in order to get performance, we will implement some best practices such as the entity graph, where we will add the attributes of actor and studio for efficient and eager loading. We will use transactional read-only true so that it prevents lazy loading issues, and we will streamline entity relationships by using one-to-many for studio to movie and many-to-many for movie to actor. Now let's go to GitHub and the course documentation, and we'll go down to Java Persistence API and Hibernate ORM with Jakarta JEE 8. And once we select it, we will select using JPA with Spring Data Repositories. And here is our lesson overview using Spring repositories and transaction. So we'll introduce Spring Data Repositories and transaction management for efficient data access and consistency. So here is a code example of a movie repository that extends a JPA repository with movie and long. We have an entity graph with actors and studio, and find all that returns a list of movies. Then we have find by title containing, returning a list of movies. Then we have a query, find by studio name. Then we look at the movie service, where the movie repository is auto-wired. And we have a transactional method, update movie title, passing in the ID and the new title. We find the movie by ID, and we throw a runtime exception when the movie is not found. Then we set the movie title. So here the movie repository includes the derived query method and a custom query to find movies by studio name. The entity graph ensures actors and studio are fetched eagerly, and the transactional annotation ensures the update operation is atomic. Now we look at configuring persistence with the Spring framework. our persistence XML. We specify the classes used. Then we specify the properties for the JDBC data connection, and we specify the Hibernate option. This configuration sets up a MariaDB database for your movie-related entities, studio, movie actor, aligning with the Jakarta Enterprise 8 JPA requirement. The persistence unit defines the necessary JPA configuration for resource local transaction. Now we'll look at creating and using the JPA repositories. The first example is all our entity classes, starting with movie, the generated ID, many to one, fetch lazy join column to movie studio, the many to many fetch lazy join table with movie actor, and the list of actor. Then we have the studio entity with the generated ID and the one to many relationship with movies. And we have the entity actor with the generated ID and the many to many relationship with movies. The movie entity has a many to one relationship with studio and a many to many relationship with actor. The entity graph ensures relationships are eagerly loaded when needed while keeping default fetch types as lazy. Then we have our data transfer object. So here is an example of the movie data transfer object with the fields and then our constructors and getters and setters. And here is our movie service where we have the movie repository auto-wired as well as a model mapper. And we have a transactional get all movies returning a movie data transfer object where we get it from the repository and then we convert it to the data transform object. And here is our convert to data transform object method where we use the model mapper. We set the studio name, we set the actor names, and then we return the data transfer object. Now when we look at the explanation, the movie data transfer object flattens the entity relations, studio and actor, into simple fields like studio name and actor names. The movie service handles conversion between movie entities and movie data transfer objects using model mapper, ensuring that actors and studios are fully initialized. The transactional in get all movies keeps the session open while fetching movies, avoiding a lazy initialization exception. Some notes on the integration. Here's our entity relationships again. Studio to movie, one to many, movie to actor, many to many, consistent with our database design. The examples use JPA 2.2 annotations, which are part of Jakarta Enterprise Edition 8 and are compatible with OpenJDK 11's runtime. Then we look at the simplification. The movie data transfer object avoids exposing full studio or actor objects, aligning with our database structure. And our performance optimization is entity graph, which ensures the relationships are loaded efficiently, transactional read-only true, which prevents lazy initialization exceptions while keeping transactions read-only for better performance. And now back to Eclipse, and we look at a main method movie app where we demonstrate the Spring repositories. So we start with creating an application config application context using our Java Spring config with our data source, our entity manager factory, our Hibernate properties, our transaction manager, and our model mapper. Back to the movie app, then we have the movie service, and this includes the 3 repositories and a model mapper, get movie by ID, create movie, update movie title, get all movies, which is the one we will use in our demo. Go back to get all movies and then convert to data transfer object, where we use the model mapper to set the title, set the studio name, and we ensure the actors are initialized. And then we have convert to entity for the movie, where we use the model mapper, the studio repository, we set the studio, then we get all the actors and we add them to the actor repositories, and we set them in the movie and we return the movie. Then we just check if the movie is empty, or we loop through the movies and list it. We use the application context where we close it to ensure that all the other open assets will be closed. So let's run it. Run as Java application. And here we have the output. We have our Hibernate select statement where we see it gets the movie, the studio, the actors from movie with a left outer join to studio and a left outer join to actor 1, actor 2, and actor 3. And then we loop through the movies and we get back the movies. So I'll leave it for self-study to go back to our data source explorer, check your database and compare to make sure that it maps what the movie app brought back. And that concludes this tutorial. I will see you in the next one.